So the last two properties we're going to cover in Unit 4 are section modulus and radius of gyration. Both are measurements of resistance, and section modulus is the measurement of resistance to bending in a beam, and radius of gyration is the resistance to compression in a column. So I'm going to jump to section modulus in the text. If you've already downloaded this text, you're going to have to download it again because I've updated it once again. And then I'm going to jump to example 5. So, well, let me go back up here. So your section modulus is equal to, will be defined with an S, and then it is equal to your moment of inertia divided by the distance to the farthest, how do they say that? Farthest fibers in a beam, a most remote fiber from the neutral axis. So I'll show you what that kind of means on one of the angles, but a symmetrical part, it's just going to be the distance to your neutral axis. But if it's an unsymmetrical, you're going to have to calculate the distance that is the greatest distance from the neutral axis to one of the edges of the part or beam. So we know that our moment of inertia equals, if it's just like a rectangular shape, is your base times height cubed divided by 12, and your neutral axis is just your overall height divided by 2, if we're talking about the x-axis. If it was the y-axis, it's just going to be your base divided by 2. And then for your moment of inertia, base cubed times d. So plugging those into the equation, we can simplify that down. So S equals, this is just for rectangular shapes, S equals your base times d squared divided by 6. So if we come to example 5, they're telling us to look at a 12 by 14 wooden beam and look at table 4.1. So if you click on that, that's going to take you down to the bottom of the screen, which then has a link to Google Sheets. So when you have that open, if this doesn't show up, there should be a little filter button here. That is located under Data, turn off filter, and then to turn it, if it's off, go to Data, whatever, create filter, and then that should create filters for this, and then you can click on this button here, and then let me get this a little bigger for a second. I'm going to click clear and then type, it's a 12 by 14 and then check that and say okay. Now that filters it out to find the beam we're looking for. I'm going to go back up to example 5. So our equation is going to be our base times depth or height squared divided by 6. So we can see that the dress size of this is 11.5 by 13. So our base is 11.5 and our height is 13.5, which I have filled out here. And then for our section modulus, I'm going to press equals base times depth squared divided by 6. Press enter. And then you can see in the table itself, it also has that number, so we know we've done it correctly. Okay. Now going on to our example 6, we're going to do an I-beam, which is table 4.2. Once again, that's down at the bottom. I already have the tab open. Same thing with that filters. I'm going to click on the filter here. I'm going to clear all the selections, and then I'm going to type in a W12 by 19. W12 by 19. And there it is. Check it, and okay. Some of the values in here were rounded, so if you don't get the exact number on the section modulus for this, that's just kind of a rounding thing. So as long as it's near it, we're good. So as I said before, section modulus is your moment of inertia divided by the most remote fiber from the neutral axis. So this is symmetric part, so that's just wherever it's just going to be your depth divided by 2. So that's what I did here on C. I took the depth divided by 2. Now down in section modulus, I can go my moment of inertia divided by c. And that gave me 21.38, which is pretty close to what they have here. So this must have been somewhat rounded from the table I found to make this whole chart table thing. Okay, there's not an example for this one, but let's just take one of these. I'll just take the first one. So to calculate the section modulus for an angle, because it's not symmetrical, we're going to take we know the moment of inertia, so let's say in this case it's 97.97 divided by where's that at? So our xd, that's in the x direction, and yd in the y direction. So we want the y direction because we're doing it about the x-axis. So I'm going to take my overall depth, which is 8 minus 2.41, and press enter. And I didn't put an equal sign in there, so it didn't do anything. Let me fix that. Press enter. Now we can see that that is the correct answer that's how you calculate your section modulus there. All right, I'm going to jump over to our radius of gyration, which I said is the measurement of a beam or a column to resist compression. So your radius of gyration, symbol for that is a lowercase r equals the square root of your moment of inertia divided by area. So the Excel you're going to download has 4 tabs here. There's the example, the problems, and then your example 7 for radius of gyration. So I have, once again, a I-beam. It's a 12 by 65. I'll uncheck this one. I can just do 12 by 65. There it is. Press OK. Yeah, scrolled up there. So my moment of inertia in, I think, what do they want us? This was off the x, so it's 533. And my area is 19.1. So I'm just going to press equals square root of 533 divided by my area, and press equals or enter. And I'll double check that. So our Rx is 5.28, and that is correct. So that one's pretty simple. There are a couple problems on each, 4 for your section modulus and 2 for radius of gyration.